Rather than using a software vulnerability, which might tend to be less reliable, we can try to improve our chances of successful exploitation by soliciting some assistance from our victim. A good example of this would be the Java applet client-side attack. This attack affects targets with Java installed and enabled in their browsers, a required feature for many administrators and power users. And as Java-enabled browsers can run Java applications through their browser, it's quite trivial to make our own malicious Java applet, which will execute code of our choice on the victim machine. But there's one small catch. Our victim will get a warning message before the execution of our Java payload. If the user does not understand the implications of clicking Run on this warning box, our malicious Java code will run on the victim machine happily. Let's go ahead and try this. I'll start by looking at some Java code which downloads and executes a given file. And we'll use this code to have our victim download netcat from our own attacking web server and then use netcat to send us back a reverse shell from his victim machine. I'll slightly modify our command execution syntax to have netcat send us this shell, and then save and exit the file. I'll then proceed to compile the code with a Java compiler, and once compiled, I'll go ahead and sign the Java applet. Great. So now that the applet is signed and ready, I copy it into the web root and then embed the applet in an HTML file. The URL of the file that my applet will download is provided as a parameter within the HTML file, and I'll be hosting the evil.exe file on our own attacking web server. So I'll copy the Windows version of netcat to our web root and name it evil.exe. I'll now set up a listener on my attacking machine on port 4444, and by one way or the other, trick our victim into browsing to this java.html page. The user is then presented with a message they may or may not choose to ignore, and by investing some more money and effort, warning messages such as these may be toned down even further by signing these applets with valid certificates. So this is where social engineering and pretext come in, where the client-side attack also includes an incentive for the victims to click on these links. And this is essentially the crucial point. If the user would now click Run, our compiled Java code will be executed and will receive a reverse netcat shell, as we can see here. So in this example, our code execution is much more reliable than our first exploit. However, it does rely on more user interaction, and as with many other client-side exploits, this is a balance that often needs to be considered.